Hello, my name is Manuel Rivera, and I'm from a graduate student from the university at Texas Rio Grande Valley. Today, I'm going to be helping you understand a Calculus 1 question from the Spring 2016 SU Boulder, which is question 3, problem B, which states the following. Find the area of the region bounded by the curve y equals x plus 1 divided by x squared plus 1 and the x-axis for x is bounded between 0 and the square root of 3. So if we look at the function, we can see that from x being greater than or equal to 0 and on, the function is positive. Therefore, we don't have any problems. So here let's look again at the function. So it says y equals x plus 1 divided by x squared plus 1. So let's divide this into two terms. So we can write the function y equals x divided by x squared plus 1 plus 1 divided by x squared plus 1. So we want to take the integral of each term. So we're going to have the following. So we want the integral of y, which is going to be equal to the integral of x divided by x squared plus 1 dx. As I mentioned, the boundary is between 0 and the square root of 3. So we can write those are our boundaries. Plus, and it's being square root now. Sorry, the integral between 0 and square root of 3 of 1 over x squared plus 1 dx. So let's look at the first integral that we want to work on. So if we look at it, we're going to need to use the substitution rule, which we're going to obtain the following. So we have the integral between 0 and square root of 3 of x divided by x squared plus 1 dx. So as I mentioned, we're going to use the substitution rule, which we're going to obtain the following. So let's write u being defined as x squared plus 1, which is our denominator, and du as 2x dx. So if we look at our function here, sorry, our integral, we have x squared plus 1 on the denominator, so that's going to be our u, but our numerator only has an x, and our du here is equal to 2x dx. So here, let's divide by 2 so it can correspond the same terms. So we have du now divided by 2 equals x dx. So by substitution, we have the integral of 1 over 2 times 1 over u du. So I just wrote, even though we mentioned du over 2, I just wrote it as a fraction next to it as 1/2. In addition to that, our boundaries also change. So we have u equals x squared plus 1. So if we substitute 0 for that, we obtain 0 squared equals 0 plus 1, that'll be 1. So our boundary changes to 1. The same thing we have to implement with the square root of 3. So square root of 3 squared equals 3 plus 1 will be our 4. So let's take the integral here. So we're going to have the integral of 1 over u is natural log absolute value of u. So we're going to have 1/2 times natural log of u, and our boundaries is going to be between 1 and 4. So let's go back and look at our other term. So we can finish that one in a second, but let's go back. So we have the integral as well between 0 to the square root of 3 of 1 over x squared plus 1 dx. And if we recall our integral table, or if you probably seen that before, that integral is the arctangent of x. So here I'm gonna write plus the arctangent of x. And this one is, our boundaries are still 0 and the square root of 3. So let's simplify our solution. So by substituting, so now let's substitute our values, our boundaries. So for example, on the first one, by substituting 4, we are going to obtain the following. So we're going to have 1/2 natural log of 4. Then minus the 1/2 as well, natural log of 1. But we know that natural log of 1 equals 0. Therefore, this whole section will equal 0, because 0 times 1/2 is 0. So let me just rewrite that as well. So this is just 1/2 natural log of 4. So now let's look at our other solution that we obtained. So arctangent of x. So we're gonna have arctangent tangent of square root of 3 minus the arctangent of 0. And we can see that by evaluating each one, we obtain the following. We obtain the arctangent square root of 3 will equal pi divided by 3. And our tangent of 0 equals 0. So our final solution is 1/2 natural log of 4 plus pi over 3. So that would be our final solution. Thank you.